Okay, so this is problem 101 on page 143. We have an inclined plane. With a block, a pulley, another block hanging. They give us the angle here is 37 degrees. And they tell us that M1 is 8 kilograms, M2 is 16 kilograms. They tell us the coefficient of friction, of kinetic friction, between M1 and the inclined plane surface is 0.23. And we're moving in this direction. So acceleration is in this direction, so that means acceleration is in this direction over here. Okay. The question asks us when it's released from rest, what is the acceleration of block M1? Since it's connected by a string here, M1 is going to go up the ramp, M2 is going to go down the ramp. Whatever acceleration M1 has is acceleration M2 will have. I'm going to break this into two parts. Part 1, part 2. And where I cut this in half is at the pulley. And since I'm cutting this string in half, that means, or the cable or rope, whatever it is, that I have T here and T here, and these two T's are equal. All right, they're pointed towards the cut, and they're equal to each other. All right, so let's start labeling forces. Every object has a force due to gravity. It's sitting on a surface, so it has a normal force. It's moving in this direction, so that means force due to friction is in that direction. On side 2, every object has a force due to gravity. And I'm going to call this one FG1, this one FG2, just so we can keep that clear. I'm looking for acceleration. And probably the easiest side would be side 2. It has acceleration on side 2. So let's just try and solve it over on this side because maybe the setup of the problem doesn't require us to do both sides. And this side is the easiest, so we'll start over here. So in part 2, I'm going to make this my coordinate system. And so I'll do sum of the forces in the y direction is T minus FG2. But Newton's second law says M2A is the force on this side, so that has to be equal to the tension in the string minus force due to gravity 2. So T minus FG2 is M2G. Mass of object 2 times gravity. So I know M2, I know G, I know M2, I don't know A, that's what I'm looking for, and I don't know T. So I have one equation, two unknowns, so I'm stuck. So I need to go the other direction. Well, the other direction on this side is the x direction, and there's nothing going on in the x direction. So now we're stuck on side 2. So we've done both directions on side 2. We're still stuck. We have one equation, two unknowns, so we have to go over to the other side. So now we're going to do, this was part 2. Now we're going to do part 1, or side 1. And what I would like to have over here is T. So if I could find T over on this side, and I could plug it in here and solve for A. So I look up here and I see T is in this direction. It's parallel to the surface. So I'm going to go ahead and make my coordinate system this on this side. And kind of the rule of thumb is to put positive x in a direction of motion. That usually gets rid of the majority of the negative signs. So I have positive x going up the ramp, and then y going perpendicular off the ramp. And t is now in the positive x direction, so I'm going to do sum of the forces in the x direction. And that would be t minus ff. But then we have this force due to gravity, which is in both x and y. So I need to decompose this one. So here's the y component. I'm going to call that y1. Here's the x component, x2. And because of geometry, this angle here and this angle here are the same. So x2 is going in a negative x direction, so that's minus x2. Newton's second law says m1a is equal to t minus ff minus x2. But ff, we know, since it's sliding, the coefficient of friction is kinetic friction, so ff is actually mu k fn minus x2. x2 is adjacent to this angle, or opposite to this angle, and our hypotenuse is fg1, so it's fg1 sine of 37 degrees. That is what x2 is. And then fg1 is actually m1g sine of 37 degrees. I know g, sine 37 is just a number. We know m1. We know mu k. We know m1. We're looking for a. I don't know t, and I don't know fn. Okay. Now over here, I didn't know a and I didn't know t. I don't know a and I don't know t. So if that's all the unknowns, then I'm good. They're the same two unknowns. And so I'd have two equations, two unknowns. I can solve it. I can solve for one, substitute in the other. No problem. But this one has three unknowns, fn. So I need to figure out what fn is. If I can plug that in, then I'll have the same two unknowns, two equations, two unknowns. I can solve it. So I look for fn. Fn is in the positive y direction for part one. So I need to do sum of the forces in the y direction. And that would be fn minus y1. Now, is the block accelerating through the surface or accelerating off the surface? No. So that means m1a equals fn minus y1. But in this case, acceleration in the y direction is 0, so m1 times 0 is just 0. And so then fn equals y1. And we do the same trig, and we get that fg1 cosine of 37 degrees is equal to y1. But fg1 is just m1g cosine of 37 degrees. Now I can substitute this in for fn here. So we get m1a equals t minus mu k m1g cosine of 37 degrees minus m1g sine of 37 degrees. Okay. So now I know everything but a and t. And over here I know everything but a and t. So I have two equations, two unknowns. I can solve for one, plug into the other, and solve for a. Now, solving for t here and plugging it into t here is going to be ugly, right? So I think it would be easier to solve this one for t, substitute it in for t here, and then solve for a. I think that's the better option. So let's go ahead and do that. So t equals m2a plus m2g, which is, and I'm going to leave that just like that. Now I'm going to bring this Actually, I'll write one more time here. So M1A equals M2A plus M2G minus mu K M1G cosine of 37 degrees minus M1G sine of 37 degrees. We're going to, we have everything now except for A, so we need to solve for A. And in order to solve for A, I need to get, since there's two A's in this equation here, I need to get all the A's on one side, factor out the A, and divide away everything else. So I'm going to subtract M2A. Okay. Now, there's an A in both of these, so I'm going to factor that out. That's why we moved M2A over. Now, if I notice, if we look at this here, on this side, we have a G here, a G here, and a G here. So I can factor out the G. Okay, I'm going to divide this over. I'm going to bring it up here so we can see it. So we'll have A equals G M2 minus mu K M1 cosine of 37 degrees minus M1 sine of 37 degrees divided by M1 minus M2. All right, so now we can start plugging in numbers. Now, the book uses 9.8 for G. I'm not sure exactly what gravity is in this room, but we're just going to use 10 for gravity so that we don't have to make the math a little bit easier. So we have 10 times 16, parentheses 16 minus 0.23 times 8 times cosine of 37 minus 8 times sine of 37. All that divided by 16. So we made a mistake. Yeah, it should be plus. And the reason for that is if we look over here, M2A, which way is A going? Down, which is in the negative y direction. So this should be a minus here, right? And so then when we add this over, it would be negative M2A plus M2G equals T. So that makes a negative right here, which when we move it over, we'll make this a plus, make this a plus, and make that a plus. Okay? Another advantage of doing this symbolically till the end and then plugging in your numbers. So if you notice that you make a mistake like that, you can go back and correct it pretty easily and find, instead of the numbers getting mushed together, you can see all the different variables. Okay, so 16 plus 8, 24. Now we can put this in our calculator. So we have 10 parentheses 16 minus 0.23 times 8 times cosine of 37 minus 8 times sine of 37. And that's the whole top. Make sure that, see, so I was in radians, so I'm going to switch over to degrees. And I'm going to do the same thing. So I did second entry, so I didn't have to retype it. All right, so there's the top. We divide that by 24. And we get A is approximately 4.05 meters per second squared. Okay.